Mm. Yes, yes, right. Uh, and the other thing, right? Especially when we start this lesson, what I wanted to say, right? Your preparation by your side, right? Now, especially if you started limits with a big book, right? So you can continue differentiation with the limits book, doesn't matter. Clear? Or else, right, you can be prepared with the separate books, right? But anyway, actually preparing with a book is up to you, right? Because sometimes you can have a bookmark with the previous lesson, right? Now suppose that you stop quadratic, right? After writing in one full book, right? So you have taken another big book, right? With suppose that with the pages like yeah 200, 300, right? Then if it is remaining, right, you can have a bookmark and continue writing, right? That is up to you, clear? But anyway, uh, especially, right, you know that for your applied mathematics, right, that means for the coplanar forces, right, you can continue one book, right? Don't mix coplanar forces and limit differentiation together, right? But actually if you feel that the you have enough space in the limits book, right, then just continue, doesn't matter. Clear, right? The selection up to you, right? But the thing is, don't keep, right, don't keep that all the books in halfway. Clear, right? So you write quadratic and finish that book, and you take another book and written in that book taken like suppose that 50 60 pages. Now there are about 120 30 remaining, right? So if so, you better use it. Clear, right? Actually I observed by past students also, right? I can remember one student, right, made a lot of spaces in the books, right? Don't keep like that. It actually is a waste, no, right? You are not earning, no. Your parents only earn it, right? So therefore, right, you better try to use maximum. Clear, right? අපි කියන්නේ සිංහලෙන් අර පිරිමැස්ම කියලා. හරි. ඉතින් අර පිරිමැස්ම තියෙන්නත් ඕන. හරි. Right. Then anyway, uh, and the other thing, right? Now you know that especially in our combined math syllabus, right? In our combined math syllabus, right? We discuss a lot in algebra. Can you remember, right? We discuss polynomials. We discuss actually partial fractions, then quadratics, then inequalities, then modulus, actually exponential, logarithms, that everything. Clear, right? That is the algebra part, right? And you know that you learn total trigonometry now, right? Actually you must be happy, right? Because you finished trigonometry earlier than all others, right? And not only that, we finished the whole part of the trigonometry, right, theories, right? But later we have to discuss further questions in trigonometry, right? And you learn the introduction part of the coordinate geometry. Can you remember, right? We know how to find out the distance between 2 points, right? We know how to find out the gradient if you are given 2 points, right? That means gradient of the line, clear, right? And you know how to find out the equation of a line if you are given a point and the gradient, right? You know how to find out the equation if you are given 2 points, right? Yes, you know how to find out the parallel lines, perpendicular lines, clear, right? This is what we finished, right? And can you remember in algebra, right? We discussed one important lesson at the beginning, right? What is that? Functions, clear? Now we are talking limits of a function. Now we are talking the differentiation of a function, clear, right? Then what does mean this differentiation? Actually, this is this idea is already with you. The main problem with the new word, clear? That's the only thing, right? So please understand carefully, right? Because you know how to find out the rate of change, right? We are calculating rate of change most probably with respect to time, right? If a particle is moving, right? If a particle is moving always 2 meters in each second, right? Clear? If it is traveling always 2 meters in each second, right? You know that the speed actually 2 meters per second, right? That also rate of change of the displacement. Clear? If something is moving uniformly like that, it's okay, right? But you know that there are some motions that non-uniform also, right? අපි ගත්තොත් එහෙම නිකම් මැස් එක කියමුකෝ මේ මැස්සගේ ගමන් මාර්ගය හරි එයාගේ පාත් එකක් අපිට ඕන නම් mathematically model කරොත් ඒ situation එකේදී right speed එක check කරන්න පුළුවන් right and you know that there are some objects right especially in electronics electricals also right now some particles may be moving right under actually inside of a what actually magnetic field or something like that. Clear? For those things also we can apply differentiation. You know that mainly you are doing maths means majority are trying to do engineering or some science subjects. Clear? Right? Then in future, right, you will be applying this differentiation directly. Clear? But understand differentiation is done not only by math students, right? Whoever going to do advanced, that means actually higher education, right? In whatever subject stream, right? Clear? Not only in maths, right? If actually, you know that medicine, right? For the ones who are studying medicine also needed mathematics, right? The ones who are going to do that microbiology or molecular biology or whatever also, right? Needed differentiation, right? So the ones who are going to do agriculture, right, need differentiation, right? So now understand, right? This differentiation is applicable, right, in all the fields, right? What you are going to apply in your higher education. Clear, right? Then actually, you know that not only that, especially commerce students, right? I conducted lectures for that chartered accountancy courses, right? You know that there are some when the students, right, are following that accountancy courses or management courses or whatever, right? So they have to learn mathematics, right? Then yeah, I conducted lectures those days, and I taught that differentiation, but not like A-level combined maths, right? But we are talking that differentiation of the algebraic functions, right? So you know that in industry or in business, right? Uh, if a particular factory produces items, right? So we want to find out the actually cost as a function, right? So we can model revenue as a function, right? So we can model profit as a function, right? Clear? So therefore, you can find out at what production level you get the maximum profit, because you know that when you are going to produce an item, right? If you supply more and more, the demand will be less. Clear, right? And you can have a very nice practical experience. You know that especially in phone, actually, listen carefully, right? Now, when you talk about the mobile phones, clear, right? When you talk about the mobile phones, right? Uh, in mobile phone industry, right? So what you can see, right? Uh, especially, you know that when you have experience with the Nokia phones, right? Uh, what have you seen, right? Can you remember in one particular type of this brand, clear, right? They are producing up to a certain level, right? Now, as an example, Nokia 1100, right? They produced and they came up to a level, right? Then stopped producing those phones, right? Then they went to the other model, right? Then they upgraded to the other model, right? Why is that? Right? And even in Samsung and in all the things, right? You know that sometimes J series or whatever series, there are different series, no? Right? Actually, the difference of those different series also not that much. There's a very small different feature. Clear, right? But what is the marketing idea of that, right? So they wanted to have a demand. Clear? They wanted to have a demand and they wanted to stop at a level, right? So that is the maximum profitable level of the production. Clear, right? So that's why they go to another one, right? And they produce that one also. Clear? So something like that. After learning these things, right, you can have a lot of experience in industry also. Clear, right? So something like that. Anyway, Differentiation, that means derivatives, is applicable everywhere, right? In commerce stream or art stream, or right, yeah, even in sociology, right? Even in sociology and some other subjects also, this differentiation is applicable. Clear, right? So therefore, right, we are going to learn, right, this part actually something in advanced manner, right? Actually, after select to the university, right, you can teach to the other people who are in following different courses. Clear? Even in our time also, we can remember, right, some of friends in other faculties, right, especially management faculty, arts faculty, right? So they are coming to our hostel to take a kuppi, right? Do you know what does mean kuppi? Right? Kuppi means, right, you just take the uh, idea from a friend quickly. Clear, right? Idea of the subject from another friend, that is called kuppi. Clear, right? So you are taking, they are coming to take actually kuppi, right? Even we are also taking kuppi from our friends sometime, right? If we missed a lesson, right? So we meet them and we are asking from them, right? Then we take the idea. Clear, right? Right. Anyway, then actually, right, this differentiation is that much practical subject, right? So it's very important, right? Actually, I will explain first how to differentiate a function at the beginning for a certain time. Then we can discuss further theory. Clear, right? Okay, now I will take the idea like this, right? So you know that if you go for this function, right, y equals 3, something like this, okay? Y equals 3, right? So this is y-axis, right? Suppose that this is 3, then y equals 3 is a graph like this, clear? All right, okay, now, Idura, can you hear me?
Sir,
What is the gradient of this line? Y equals 3.
0.
The gradient is 0 because slope is no, right? No slope, that means 0, right? Now, you know that when you go for a function like this, right? Especially, anyway, now, you know that x equals 1. Suppose that x equals 1 here, right? This point is 1, comma 0. X equals 1, right? Now, you know that x equals 1 is a vertical line. What is the gradient of this vertical line? Indra?
Infinity.
Infinity means undefined, right?
Undefined. Yes.
Directly, the gradient is undefined, right? So, you know that vertical lines have undefined gradient, right? Then, if I go for this function, actually y equals x, right? It's a function. No? I told that this is one of the best functions, right? So one-to-one relation. When x takes 1, y also takes 1, right? When x takes 2, y also takes 2. When y takes 3, x also takes 3, right? So it's a very good relation. If you could find out such a relation in future, that's great. Clear, right? But don't expect always. Clear, right? It's very rare to add two functions, two variables like that. Clear? Okay, but anyway, then what you can see, right? Y equals x like this, right? Now, is this a function? Yes. For one x value, we have one y value. It's a one-to-one relation, right? So what is the gradient? What is the gradient, Idra?
1.
1. Clear, right? So if you have y equals 2x plus 3, something like that, right? You know that if you have a function y equals 2x plus 3, so actually here this is 0.3, right? The gradient is 2. So you can see that it has a constant slope, right? It has a constant slope means actually the function has a constant gradient, right? That's what you can see. Okay. Now I will come to this function, right? If you come to the function y equals x square, right? I think you are familiar with this graph, right? Because we discussed much, right? This is the basic quadratic function that we have to memorize, right? So this is the graph, okay? Now, what is the gradient of this function, Indura? Y equals x squared. What is the gradient of this function? Yes, good, right? So you are having a problem, no?
Yes, sir.
Means, yeah, right? That's the answer. Clear? Now, when you go for a function like this, y equals sin x, right? Actually, I will take a small part of the graph, right? Then anyway, you know that if I draw the parallel lines like this, you will be having a curve like this, right? Now, what is the gradient of this curve, right? Uh, uh, uh. Yeah, that's the answer, right? Then if you go for the function y equals ex, right? I think you are familiar with this graph, right? Xy. Then yeah, the function is like this. Okay? It's a very rapid improvement, right? You know that exponential applications, right? Corona is the best example for that exponential, right? And you know that actually in physics you learn carbon, no carbon, what is called that? Carbon, what is called either a carbon measurement? No.
Sir?
What is that you are measuring that the age of the some uh, yeah, if you have any, you are measuring
Carbon 14. Sir.
Carbon 14 measure, no? Right? Right. So something like that. Clear? Right? Actually, that also, yeah, carbon dating, right? Yeah, right. That is uh, that particular calculation also based on the knowledge of exponentials. Clear? Right? When you learn at the physics at last, right, you will be able to understand that, right? There's a formula, right? You can calculate with that formula. Okay. Now, anyway, so something like that. These all are functions, right? Now, if I ask what the gradient of this function, right? You know that these constant lines have constant gradients, right? But you can see that these curves, right? These curves, right, don't have a constant gradient, right? So if I ask, right, what is the gradient at the origin? So you have to draw a tangent, right? The tangent is horizontal means gradient at the origin is zero, right? Then if I ask what is the gradient at 1 comma 0, okay, then you will be having a tangent like this, right? So this is the slope, right? Then if I ask what is the gradient at 2, you will be having a tangent like this. Now if I mark this gradient m1, this gradient m2, you can understand clearly that m2 greater than m1, right? That means when x increases, the gradient also increases. Okay. Now, in this side, what you can see here, here you will be having a greater negative gradient, right? At this point, there will be a lesser negative gradient. Then you can see that actually value by value, the gradient value is decreasing, but negative gradient. Okay, right? So negative gradient, zero gradient, positive gradient, that positive gradient is increasing, right? So this is what you can see, right, in a curved function. Actually, when you take the function quadratic, its graph is curved. So that what you can see the gradient of a curve. Clear? Similarly, right, you will be able to understand if you have a curve, right? Actually, if you have a function with a curved graph, right? If you are given a function with a curved graph, right? That means if you are given a function, you can sketch the graph. If the graph is a curve, right? So they don't have fixed gradients. Now, actually, the simple idea of differentiation means actually finding the rate of change. Clear, right? Simple idea is what? Finding the rate of change, right? Actually, uh, that's what if someone asks just as a question without much mathematical terms, right? But if someone asks what is the differentiation, right? If that person is familiar with the knowledge of the functions, so you can say that actually, if you take the graph to a function, right? If you take a graph to a function, right, and if you draw a tangent to the function, the gradient of the tangent, right? The gradient of the tangent says, right, actually differentiation, right? That means anyway, you know that here we are talking about that functions and application. That means we are finding the gradient of the tangent drawn to a curve, right? We are finding the gradient of the tangent drawn to a curve at any point on the curve, right? Simply, right? And further, actually, right? If someone asks what does mean differentiation, right? So you will be given a function, right? So if someone asks what is differentiation, how do you say? If you are given a function, you find the gradient function. Finding gradient function is called differentiation, right? That's a simple idea, right? Okay, now actually if I go, right, if I go for the Dismos calculate, right, yeah, I can explain you further by that, right? See here. Okay, Idura, can you see the screen?
Yes, sir.
Yeah, now actually you can see here, right? Yeah, now you can see that, especially see, right? Especially differentiation means, right? You are given a function, right? The function fx is this one, okay? Then its gradient function is not given, but anyway, right? We don't need that part. Now understand, actually, if you change this one, right? Can you see the gradient change? Because at this area, the slope of the function is high. That's why you get a higher slope like this, right? Anyway, I will start from this point. You can see that in this area, the gradient is negative, right? Actually here, right, gradient is 0 at this point, right? Now this red line is the tangent. Now you can see that actually slope of the tangent is increasing. That means actually the gradient of the function also increasing and then start decreasing, uh, decrease in the rate of increasing actually. And here again horizontal, right? Actually at this point, suppose that here, right? I can't take exactly the point. Somewhere here, right? Then actually, so this is called a stationary point. Then again, negative gradient. That means function is decreasing, right? Then actually still decreasing. Then again increasing, right? And horizontal, right? Then actually decreasing. So it goes like that. Okay. Now, so you can understand for different a values, right? What is the yeah, for different values of a, right? The nature of the gradient, clear, right? When a increases, understand how the gradient changes, right? Right. Okay. Now, I think you have some idea about that, right? Then uh, here also you can understand what will be the gradient. Okay. Right. Now, write down. Consider the following functions. Consider the following function. Consider the following functions. Take this one as the first one. Y equals 3. And take the rough sketch of the graph quickly. Okay, then write down under the graph a constant function, the gradient is 0. A constant function, the next line, the gradient is 0. A constant function, the gradient is 0. Next, second one, x equals 1, right? This is a quicker revision of the function, right? Okay, now under that you can write an equation, right? Actually, not a function, clear? An equation, even you can write within bracket, not a function, right? Not a function. The gradient is undefined. An equation, right? And within bracket, not a function. And the gradient is undefined. Third one, right? Y equals x. They are within the write down a linear function, a linear function, a linear function. Then take the graph. Y equals x, then within bracket linear function, then take the graph. Then write down the function has a constant gradient. The function has a constant gradient. The function has a constant gradient. Not in that part, right? So you can go for this y equal x square. Take just the parabola only. And if you want, you can draw the tangents like this. Yeah, better, right? Draw the tangents at different points, right? Yeah, something somewhere here, somewhere here, somewhere here, somewhere here, right? Like that. Y equals x squared. Okay, then I think you have drawn some randomly marked points and their tangents, right? Under the graph, you can write the function is a curve graphically. The function is a curve graphically. The function is a curve graphically. A curve doesn't have a constant gradient. The curve doesn't have a constant gradient. Then the gradient also a function of x. Then the gradient also a function of x, right? You can understand that one further through examples, okay? Right? The gradient is a function of x. Right, okay, then write down finding gradient, finding gradient, finding gradient, finding gradient within bracket or the gradient function, finding gradient within bracket or the gradient function. Of a function given is called derivative. Finding gradient within bracket or the gradient function of a function given is called the derivative within bracket differentiation, right? Within bracket differentiation is called derivatives. Actually, within bracket differentiation, full stop, right? Okay, then right now let y equals fx is a differentiable function of x. Let y equals fx is a differentiable function of x. Let y equals fx is a differentiable function of x. Let y equals fx is a differentiable function of x. Then the differentiation of y with respect to x. Then the differentiation of y with respect to x. The differentiation of y with respect to x is denoted by dy by dx, right? Actually, don't misunderstand that dy by dx, right? Then dd cancel and y of x, clear, right? Actually, this is just a particular command, right? What the command says, differentiate y, otherwise this function with respect to x. Yeah. That's the simple idea of this notation, right? Dy by dx. Also, it is further denoted by f dash x. Also, it is further denoted by f dash x. Also, it is further denoted by f dash x. Right. Okay. Then actually, at the beginning, I will explain, right, the techniques of differentiation. You know that, no? Right. These are new lessons for you, right? You never learn early. Clear, right? So therefore, right, first we should be familiar with the uh, questions doing. Clear, right? Then after being familiar with that questions, right, then actually you can get the idea and concept very easily, right? Otherwise, if you don't know what's this, and if you know any idea about this, if I'm trying to explain further, right, you can't take much. Clear, right? Because we are single again, and they are kirigan again, right? Pain nothing is to visit that and then, right? So something like that, right? But anyway, then now, under that, right, first write down, uh, yeah, the methods of, yeah, the methods of derivatives. Write down subtopic, the methods of derivatives. The methods of derivatives. Methods of derivatives. Right. Okay, then, under that, first one, put a stand write down. Let y equals k is a constant function. Let y equals k is a constant function, right? Let y equals k is a constant function. Right, now, because of you are okay with the graphs, right? Imagine y equals 2, imagine y equals 5, imagine y equals 2022, whatever, right? You know that constant functions have always horizontal lines, right? So the gradient of a horizontal line is always, earlier, you also said that, what? The gradient of a horizontal function is always 0 because slope of a horizontal line is 0. Clear? I'm proving this, all the things, don't misunderstand, right? I'm proving, right, everything mathematically with the definitions, right? Until that, right, we should be familiar to do questions, right? So anyway, you know, simply, right, constant function has 0 gradients. So therefore, actually, here dy by dx equals 0, right? Clear? If you have a constant, the differentiation of a constant is 0, right? That's what you have to take. Then මේ කියන ටික ඕගොල්ලෝ follow කරන්න. එච්චරයි. තව සති ඊළඟ second week එක වගේ යනකොට තනියෙන් හැමදේම කරගන්න පුළුවන් confidence හැදෙනවා. Right? So until that, just follow my instructions. Clear? Right? Okay. Then next, right? Okay. Then anyway, write down if y equals k, right? Then therefore dy by dx equals 0, right? The gradient of a constant is 0 always. Right, second one, write down. Y equals x to the power n. Write down where simple n is a real constant, right? Where simple n is a real constant, right? Please understand it's a constant, right? Because of x is the variable, n is a constant, right? Why is n is constant? Because of x is the variable. Clear? Right? Y equals x to the power n, right? Then If y equals x to the power n, now understand the way of differentiating. Clear? Right? You can write actually dy by dx equals, right, n x to the power n minus 1. Clear? This is our first differentiation techniques, right? At the beginning, I'm giving that all the techniques first, right? Then understand if you have a function y equals x to the power n, then dy by dx is nx to the power n minus 1, right? That's how we take the gradient function. See, very simple, right? I will go for examples, right? So you know that y equals x squared, right? If you have this y equals x squared, compare with this, x is already there. N is 2, clear? Then how do you take the gradient function? Dy by dx equals n, that means 2x to the power 2 minus 1. That means anyway, the answer is 2x. Clear? So you can see that gradient is a function of x. That's why I told gradient is a function of x. See? Right? Okay. Now I will explain actually further, right? Because of I explained the graph, you know that here x and here y. Clear? Then when you go to the graph, right? You know that in this particular parabola, right? Clear? In this particular parabola, right? Now, if I ask the gradient at x equals 0, right? What do we do? It's a variable thing, no? Right? You can see that when x equals 0, right? dy by dx equals 2 into 0. The answer is 0. dy by dx is the gradient. Gradient is 0. 0 gradient means a horizontal line. Correct, no? So you can see that, right? If you draw a tangent, right? If you draw a tangent at this point, it's the x-axis. Actually, tangent coincide with the x-axis, right? Now, if I ask, right, what is the gradient when x equals actually 1, clear? So you can see that actually dy by dx equals 2 into 1, which is 2, clear? Now, x equals 1 means maybe somewhere here, right? At this point, clear? At that point, if you draw a tangent like this, clear? This particular tangent has the gradient 2, clear? If I ask when x equals 3, right? So you can see that dy by dx equals actually 2 into 3 means 6, right? And now if I draw a tangent 1, 2, 3 somewhere here, now suppose that somewhere here, right? Then actually you will be having a line with the slope that much. Clear? That means here the gradient is 6, right? So you can see that actually when you increase the x values, right, the slope is increasing, right? I explained with the Dismos calculator. Imagine with that, right? If you draw, if you move a tangent always to the curve, right, its slope is increasing like this. Clear? Now, if I ask the gradient, right, when x equals minus 2, right? When x equals minus 2, dy by dx is minus 4, right? Because 2 into minus 2, right? That means, what is the meaning behind that? If you draw a tangent here, see, negative gradient, right? Negative gradient, right? There m equals minus 2, okay? That means understand at the beginning also, right? At the beginning itself, right? So if you are given a function, right, we find dy by dx means, right? We find dy by dx means actually we find the gradient function first, right? So the gradient function also in terms of x. Why is it in terms of x? Because it's a variable gradient, right? Now, each gradient at each point, right? can be determined by substituting the x values. Clear, right? This is a simple idea, right? Okay, now let's take this example now practically, right? And mark at the corresponding points, right? Then we can go for further functions, right? Please take this also. Now, by this example itself, right, actually now you will be having a bit clear idea, right? Not 100%, but you will be having a particular idea, right, with a clear idea, actually, right? You can write these things actually under the graph course anywhere, right, as you wish, right? Right, okay, then right, then if I take another example, right, you can see that y equals x cube, right? If you differentiate, can you tell me the answer? What is the dy by dx value, right? You know that nx, that means 3x to the power 3 minus 1, right? 3x squared. Clear? All right. If I take another example, right? Y equals x to the power minus 7, right? How do you differentiate this? Dy by dx equals minus 7x to the power minus 7 minus 1, okay? So you can write minus 7x to the power minus 8, or else minus 7 divided by x to the power 8, right? Usually we are writing always with positive indices, no? Right? We can do like that. Clear? Right? Next, if you are given a function y equals, right, x to the power, now suppose that 5 over 2, right? Actually, then you can go for that dy by dx, right? So what is dy by dx? 5 over 2, right? X to the power 5 over 2 minus 1. That means 5 over 2 x to the power, you know that 3 over 2. Clear? We can take like that. Now, if I go for another function like this, right? Y equals, right, x to the power 1/3. Clear? So you can differentiate this one simply dy by dx nx. That means 1/3 x to the power 1/3 minus 1. What is the answer? Minus 2/3. Right? I calculated quickly and wrote the answer. Right? Next example, if you have a function y equals, right? Then x to the power minus, right? X to the power minus 3 over 4, right? Then how do we get the differentiated function? You know that minus 3 over 4, x to the power minus 3 over 4 minus 1, okay? Right? Then what is the answer? Minus 3 over 4, right? X to the power, right? Minus 7 over 4, right? That's how we do it, right? And if you have a function, right? Y equals x to the power, right? Root 2. So what is the answer there? Dy by dx equals root 2 x to the power root 2 minus 1. Clear? So you can take like that. Okay, please take these examples also, right? And you can do these questions by yourself there, right? First, copy down these fast and do these 6 fast and raise your hand, right? Especially the ones who are doing quickly and raising hand, right? Your talent and you are encouraging your friends, right? So that's a good thing, right? Right, good. Himaya, Sinal, Jason, Partly, Akila, Akit, Sara, Mohammad Fas, Janiru, Dekmi, Fasler, Rahul, Seha, Ra, Akash, Nishadi, Sakit. Right, okay, now Okay, now Akib, what is the first answer?
So 11x into the power 10.
11x to the power 10. Second one also?
So minus 8 over x to the power 9.
Minus 8 to x to the power 9. Good, right? Okay, Sarah, what is the answer of the third one?
2 over 5 into x to the power minus 3 over 5.
Sorry?
2 over 5 into x to the power minus 3 over 5.
Right, good. Okay, then fourth one?
X to the power x.
X to the power x. Fifth one?
Sin x into x to the power sin x minus 1.
Okay. Then, Senal, what is the answer of the sixth one?
So x cube is x into 3x square minus 3.
Mm-hmm. Okay, then Shahara, what is the answer of the fourth one? Right, okay, then Charul, what is the answer of the fourth one? Hmm? Rahul, what is the answer of the fourth one?
So x to the power x.
X to the power x, right? Okay, then now Rahul, can you read out the definition first? The thing we found that I gave the theory, y equals x to the power n, then dy by dx. Is it there? The note.
Ah, yes, sir. Dy over dx.
Okay, no.
That is
Starting
equals
point.
to.
From the starting point, tell me. Let y equals.
So let y equals k. Then no, sorry. Let y equals x to the power n, where n is a constant.
Where n is
Then
that?
dy
Wait.
over
Where n is that?
real constant.
Real constant, right? Now, x to the power x, it is a constant?
No, sir.
No. Sin x is a variable. Sin x, constant or not?
No, sir.
Not a constant. X squared, constant or not?
No, sir.
ටොක්කක් එනගෙන ඒ ටික කට් කරලා හරි ඒ ටික කට් කරලා ලියා ගන්න, right? You can differentiate only up to 3. Clear? You can't differentiate 4, 5, 6 because the power is not a constant. Clear? Right? In a way, දෙනකොට ඔක්කොම කාගෙන යනවා කියලා කන්න එපා. සමහර වැරදි කෑම කාවම ලූස් මෝෂන් වෙනවා. අන්න ඒ වගේ තමයි මේක. Clear? Right? So therefore, write down only up to this, right? You can differentiate only up to this, right? Now you can write here, these cannot be differentiated because of the power is not a constant, right? We have techniques, but don't misunderstand, right? That we can't differentiate, we can, but in future we are having techniques. Clear? Right? Then write down, right? These cannot be differentiated by the above theorem. Don't write these cannot be differentiated, right? It's wrong. These cannot be differentiated by this method, right? Because of the power is not a constant, right? Because of the power is not a constant. Right. Okay. Then now there are a few more properties, right? Then write down. Next one. Put a and write down. Let k be a constant and fx. Let k be a constant and fx and gx be two functions of x. Let k be a constant and k, right? Be a constant and fx and gx be two functions of x. Now, this is a particular property, right? Actually, as an example, right, if I take like this, if you have y equals 2x to the power 3, clear? So, dy by dx equals, right, actually here, twice into dx cube by dx. That's the simple idea, right? So, if you have a constant, you can take the constant with the function. Don't misunderstand, this constant is not alone, clear? Right? If a constant were along, its differentiation is 0. But here, the constant join in with the function with multiplication, right? So therefore, you can keep the constant and differentiate the function. Then you will be having 2 into here, 3x squared, right? That means finally 6x squared. You can write like that. Clear? Right? Take the example also, right? And next one actually, if, right? If y equals fx plus gx, right? Actually, then you can differentiate separately fx with respect to x with plus and gx with respect to x, right? Actually, if it's with minus, you know that, no? Sorry, subtraction is a byproduct of addition, no? So therefore, if it's a minus, he also minus. Clear? Now, if I take one example, actually, suppose that you have x cubed, right, and plus x squared. If so, right, you can take this dy by dx actually as 3x squared plus 2x. Clear? Now, you know that usually we are talking everything for 2, right? No, right? I know that, no. Although we discuss everything for 2, you have to understand this is actually okay for 3, 4, 5, 6, 4 in numbers. Clear? Right? Generally, we discuss everything for 2, right? Okay, now as an example, another, right? If we have, right, y equals, right, 2x to the power 3 minus x to the power minus 1 plus 5, something like that. Clear? Then how do we differentiate? Dy by dx equals, here you can apply this property, right? That rule. 2 into 3x square minus, then minus 1 x to the power minus 2 and plus differentiation of 5 is 0. Clear? Differentiation of a constant 0, right? So therefore you will be having actually dy by dx equals, right, 6x squared and minus minus plus then 1 over x squared. Okay? Or else you can simplify, but you can leave the answer like this also. Okay? Please take these properties also. Right, I think you copied here, right? Then we can discuss few examples. Write down, differentiate the following. Right, then y equals, right, 3x to the power 4 minus 4x squared minus 8x plus 3, right? Second one, y equals x squared plus 1 into x plus 3, right? Third one, y equals x to the power 3 over 2 minus 1 into x plus 1, right? Fourth one, y equals x to the power 2 minus x plus 3 divided by x to the power half, right? Fifth one, y equals x cubed plus x plus 1 into x minus 2 divided by x, right? How do we differentiate this? I tell you that here it's very easy. dy by dx equals, first you better do by yourself. I will give you 3-4 minutes and raise your hand those who have done quickly. Who got this answer? Raise your hand those who have taken this answer. Right, good. Then actually here, first you can write y equals x cubed plus 3x squared plus x plus 3, right? Then dy by dx equals 3x squared plus 6x plus 1, right? Who got this answer? Okay, good, right? Then here you can write that y equals actually x to the power 5 over 2 and plus x to the power 3 over 2, then minus x minus 1, right? The differentiation will be then 5 over 2 x to the power 3 over 2 and plus 3 over 2 x to the power half minus 1. See whether your answer is correct or wrong, right? Then y equals actually, when you have a division like this, right? Fortunately, still we are getting with a single term like this. Clear? If so, we can do like this because x squared divided by x to the power half means x to the power 3 over 2, right? Then minus x to the power half, then plus 3x to the power minus half. See whether you can understand or not. What did I do? I divided this by x to the power half. I divided this by x to the power half. I divided this by x to the power half, right? Then dy by dx will be, right, actually 3 over 2 x to the power half and minus actually half x to the power minus half and then minus 3 over 2 x to the power minus 3 over 2. Clear? You'll be having like this, right? If you want, you can write in positive powers also, but when you have rational numbers, it is not a must like this. Clear? Right, then when you go for this function, you know that actually x to the power 4, right? Then minus 2x cubed and then plus x squared, then minus x minus 2. Okay? Divided by x. That means you can write it as x cubed minus 2x squared plus x minus 1 minus 2x to the power minus 1. First, you can rewrite like this. Then take dy by dx, right? Actually 3x squared minus 4x, right? Plus 1, here 0, right? And then plus 2x to the power minus 2, right? Or else 2 over x squared. Clear? Right? You can write like this, right? Simple, right? Okay, chat is finished.
Yes, sir.
Right. Actually, then we have another important technique, right? That is differentiation by chain rule, right? And then we can go after that. Actually, we can have the uh, best concept of this differentiation, right? Actually, we are doing that. All we are taking that all the results with proofs, clear, right? So we are differentiating by first principles next, actually, right? Differentiation by first principles is the most important thing, right? So because of we are okay with limits, we can manage it, clear? And every day, right, I'm taking almost like 1.5 hours, right? Then by the rest of the times, I'm doing further limits questions, clear, right? Now, actually, you can be prepared with the limits tute, right? Okay, then I will share the tute today. And the other thing, there's a very good document, right, in differentiation, and I shared it to the 2021 group also, right? The thing is, it's a file with more than 100 MB, right? Uh, so you can see that there are very nice pictures and a lot, right? So you can learn a lot with that book, right? So I just thought to have a Telegram group also, because you know that through Telegram we can send even that means files with big capacity, and not only that, we can share videos also through Telegram, right? So raise your hand those who are not yet in Telegram. So there's a lot, right? Now, yeah, I can put the file to the Google Drive and share the link, right? That also one option, and make it in a Telegram group. This is the other option, right? What do we do? Kavish, you all are not in Telegram.
I have an account. So I have one.
Okay. Yeah, let's try to make an account, right? So then we can share the files actually in WhatsApp. You know that we can't share the files like that, right? But through Telegram we can share the videos also. Clear, right? Okay, now anyway, we don't need to be hurry, right? Be prepared with the Telegram account, right? Uh, yeah, I will make a group within few days. Clear, right? Right. Anyway, the tute will be shared to the WhatsApp group, right? I will share the tute after this discussion, right? Then anyway, right now, please get ready with limits, right? So we have done two theorems, right? Then we have to go for questions further by that theorems, and I will again go for some further questions with the idea of the continuity. Clear, right? Okay, now open the tute. Right. I shared actually two tubes, right? Then we have discussed a lot of questions, right? Then anyway, in the in the limits review 2, right? Actually, this is the review to which I named revision, right? Uh, and 2022 dues also there, right? Now please go to the limits review 2, right? And there are some questions, right? I will explain how to get this answer, right? How to get this answer by using substitutions also. Clear? Not a big problem, but we have to discuss. Anyway, look at the page number 2, right? No, page number 1, right? The page number 1, fourth question, right? The page number 1, fourth question, eighth part. You have to show that the limit x goes to, right? Limit x goes to 1, then 2x minus 2, right? Divided by 26 plus x to the power 1/3 actually, right? Cubic root to the power 1/3 minus 3 equals 54, right? You have to show this answer equals 54. How do we do that? It's a very simple thing, right? But you know that if you substitute x equals 1 directly, here 1 means 27. 27 to the power 1/3 means anyway what happened? You get 3. Clear? Then this is, right, 27 to the power 1/3 3, then 3 minus 3 0, here 2 minus 2 0, 0 divided by 0 undefined. Clear? Then how do we get the defined value, right? So you can get this answer actually by a substitution, right? Why do we decide to go for a substitution? This power 1/3 is a problem. Clear, right? Now, what do we do actually here? You can write let. Okay, suppose that you put t equals 26 plus x to the power 1/3, right? Then by getting the cubic power, you can see that t cube equals, right, 26 plus x. Clear? Now I will write x equals actually t cube minus 26. Okay. At the same time, this is the transformation of x to t. No? Clear, right? Now see, when x goes to 1, right? X goes to 1, where to t goes? That means substitute 1 here. 26 plus 1, 27, right? 27 to the power 1/3 is 3. Therefore, t goes to 3. Clear? That's how we can write. Then we can write limit. Instead of x, we can write t goes to 3, right? Then twice into what is x? T cube minus 26. And we have minus 1 because we have taken out 2, right? Then in the denominator, instead of this whole part, you can write t and minus 3. Okay. Then you can see that here limit t goes to 3, right? Then twice into, actually if you want, you can write 2 out. Okay. Right? Then 2 out, right? Then 2 limit, you can see that t cube minus 27. That means 3 cube divided by t minus 3. Okay. What is this? Can you remember? Limit x goes to a, x to the power n minus a to the power n over x minus a, right? How do we write the answer? Na to the power n minus 1. Clear? So 3 square 9 into 3 27 into 2 54, right? That's how we get the answer is 54. Clear? Right? Okay, raise your hand those are taken this answer. All right, good. Please copy down. Okay, Amri, finish.
Yes, sir.
Right, in the same tune. Please go to the page number 2 also, right? Actually, I will discuss some further questions by limit theta goes to 0, sine theta or theta equals 1, right? Can you remember this theorem, right? I discussed two theorems with the proofs, right? Especially, yeah, after a long time because we have enough time, right? So here we can discuss a lot, right? So I discussed the proof also because in some term test you will be getting the proof. If so, don't worry, you can do it if you practice much, right? Uh, but I don't know the possibility in the examination. But being yeah, practice by practicing, right? A theorem is also one important thing in this mathematics. Clear? Right now, go to the page number 2. Right, in the page number 2, I will discuss these few questions. Right, especially go to the question number 8. Right, and I will discuss few examples by sine theta or theta equals 1 for theta equals to 0. Right, then right, next, when I go to that, go to this 8th question, right, first part. So you have to take limit x goes to 0, right? Sec squared x and plus x minus 1 divided by tan x, right? මේ ආගන්න මේ සමහර ළමයි mistakes කරලා අහලා ඉවර තිබ්බා මේ is this correct or wrong, right? ඒ වගේ අහන්නවත් ඕනේ නැහැ, right? මේ you have to understand this particular idea, right? So if you substituted this x equals 0 directly, you know that cos 0 1 means sec 0 also 1. Sec 0, clear, right? So it is 1, then 1 squared 1. 1 minus 1 0, but here 0, clear? Then tan 0 0, 0 divided by 0 undefined, right? But what I wanted to say, right? You can't substitute 0 to a part and you can put the limit in the other term, right? Now see, you just write limit, right? X goes to 0, then sec 0, then plus x minus 1 over tan x. Can you do like this? मैं एक के 0 substitute करना, अनित के ना substitute करना है, मत और ना करना, मत नेत्तन निकांगे. So you can't do like that. Clear? So you have to do the simplification and see. You are going to say, right? See, what is the meaning of this one? Right? You are going to substitute x equals 0. Right? You just mentioning that, right? You are going to substitute x equals 0, right? Then after substitution, what can still you are saying that you are going to substitute, correct? Wrong, right? So therefore, now this method is completely wrong, right? Now what you can do here, first you can simplify actually, right? See, sec squared x minus 1, you know that it has tan squared x, right? Then tan squared x plus x, right? Then divided by tan x, right? Then you can see that 1 tan x cancel, right? Then you can write limit x goes to 0, right? Tan x and plus limit x goes to 0, I'll write here 1 over tan x means actually sin x over x into, right? Then further, right? So you can see that 1 over cos 6, right? Anyway, here 0, right? See, After substitution 0, 0, right? Then don't write limit because you already substituted, right? And plus. Anyway, if you want, you can write limit there. Otherwise, 1, and here you are going to apply limit, right? So this is a particular thing what you mentioned in that you are going to substitute x equals 0. Yeah? Right? You are going to substitute x equals 0 means, right, it doesn't have numerator denominator, right? Just a particular idea, right? So therefore you can write here actually sin x over x, right? Then 1 over cos x means actually cos x. So you are going to substitute 0, right? Then what is this answer? 1. Then you will be having 1 over 1, right? Into 1. The answer is 1, right? Who got 1 in this part? Check your answers and see whether you have taken the correct answer or not. If not, please take the correct answer. And you will be able to take this answer also very quickly because you can simplify 1 minus tan x. Here cos x minus sin x and divided by cos x into cos x minus sin x. So these two cancel. Then substitute directly 1 over root 2, right? The final answer will be root 2. Check your answer. Okay, time to finish. Right, then I will discuss this question also, right? Actually, third part is very easy because same type of second, clear, right? Third one also something like the third, actually second part, right? But yeah, then fourth one also very easy, right? Um, see that fifth part actually, in the fifth part, limit, right? X goes to 0, then cosec x minus cot x divided by x, right? Then how do we get this? Now you can see limit x goes to 0, cosec means 1 over sin x, and here minus cos x over sin x, right? Then limit x goes to 0, you can see that 1 minus cos x divided by, right? X, I put 1 here, then x into sin x actually, right? This common denominator is sin x, right? Then numerator 1 minus cos x, that divided by 1 over x means multiplied by, here x over 1 means multiplied by 1 over x, right? Then further what you can do here, you can multiply by the conjugate, right? So 1 minus cos x and the other one 1 plus cos x, right? And here also x sin x into 1 plus cos x, clear? Then you can write limit x goes to 0, right? Then 1 minus cos x, 1 plus cos x means 1 minus cos squared x, right? That means sin squared x divided by then x sin x into 1 plus cos x, right? Then what happened? 1 sin x cancel, right? Then limit x goes to 0 of sin x over x into, right? Limit x goes 0 of actual, right? Here 1 over 1 plus cos x. Now here the answer is 1, then 1 over 2, the answer will be half, right? That's the final answer, right? Yeah. Then raise your hand those who have taken this answer for the fifth part, half. All right, good. Next, when you go for this one, right? The question number, there itself, the sixth part, right? Look at the sixth part. Limit x goes to 0. X plus tan 3x divided by x plus sin 3x, right? Then how do we do this? Very simple. You can write limit x goes to 0, x divided by x plus tan 3x divided by x. Actually, what I am doing here, both denominator and numerator is divided by x. Clear? Then I can write here 3 and multiplying by 3, and I'll write here 3 multiplying by 3, right? Anyway, these two cancel, then 1 plus limit x goes to 0. Actually, tan 3x, you can write it as sin 3x over 3x into, right? Limit x goes to 0 of actually 3 over cos 6, right? Now here 1 plus limit x goes to 0 of sin 3x divided by 3x into 3, right? So what is the final answer? You will be having 1 plus here 1 into 3 over 1, right? Divide by 1 plus 3. The final answer is 1. Okay. Until you are going to substitute, right? Don't until you are going until you are saying that you are going to substitute, right? Don't substitute. Here, just a constant. We don't need to say that we are going to substitute. Clear? Limit of a constant is constant, right? Please follow the instructions and steps very clearly, right? And see the way of doing the question. Okay. Then please do 10th question, first part and fifth part. 10th question, first part and fifth part. And 11th question, first part, second part. First part, second part, and third part. Actually, I have to discuss much by this one. You better try. I will give you 5 minutes, right? 10th question, first part and fifth is anyway manageable, right? But after trying, it's good to explain something further. Okay? Actually, I don't think that this is hard, right? The 10th question, first part and fifth one. You know that in the 10th question, fifth part, 5, right? You have to multiply by the conjugate of both, right? Then you can take the answer very simply, right? Raise your hand, those are taken 10th, fifth part. 10th, fifth part. Milani, what is your answer?
2, sir.
Sorry?
2.
2, right? Raise your hand, those are taken 2. 2 is the correct answer, clear, right? And here also it's okay because now see 10th question first part. Limit x goes to pi by 4. You know that you can write 1 minus tan x as cos x minus sin x divided by cos x into cos 2x, clear? Now, you know that if you substitute pi by 4 still undefined, right? Then what you can do here, right? Some students may be having a big problem, right? With this one actually. So what you can write here, cos 2x means cos squared x minus sin squared x, clear? That means limit x goes to pi by 4, you can write cos x minus sin x, right? And divided by cos x into cos x minus sin x and cos x plus sin x by the factors of difference of 2 squares, right? Then these two cancel, right? Then 1 over root 2, right? Then 1 over root 2 plus 1 over root 2, right? Here 2 over root 2 means root 2. These two also cancel, you get 1, right? Who get 1? Good, right? Now in this 11th question, first part, right? Limit x goes to 0, 1 minus cos sin x divided by sin x. Actually, if you have something like this, look at the board and understand carefully, right? It's a new type, right? Here x is the variable, right? If x is variable, sin x also variable, clear? You can manage this question also by using the substitution, right? So what do we do here? You just write let t equal sin x, clear? That means as x goes to 0, where to t goes? You know that 0 means sin 0, 0, right? T goes to 0, right? Then what do we do here? Limit, actually you can write t goes to 0, 1 minus cos t over t, okay? Then okay, no, you are familiar for these questions actually, right? Then limit t goes to 0, you know that 1 minus cos square t and t into 1 plus cos t. I think you can understand what did I do, right? Can you understand what did I do here? I multiplied by 1 plus cos t, both numerator and denominator, right? The numerator 1 plus cos t into 1 minus cos t means 1 minus cos square t, right? Then limit t goes to 0, right? Actually here sin square t divided by t into 1 plus cos t, right? Then you can write like this, limit t goes to 0 actually, sin t over t into limit t goes to 0, then sin t over 1 plus cos t. This is 1. Sine 0, 0 over 2. The answer is 0, right? Who got 0? Wow, good, right? Others, please copy down this, right? Now I think you will be able to manage second part also similar way, right? You better put a substitution 2 sin x equals t, right? Okay, first copy down this. And actually in coplanar forces also, right? We discuss line of action, and then we are going to discuss the equation of line of action also. Clear, right? So please take that idea clearly, right? So, that will be very helpful to manage all the questions by coplanar forces, right? Then the other important part is couple, right? Clear, right? Anyway, then copy down this one. Then see in the second part, limit x goes to 0, 1 minus cos squared 2 sin x divided by 1 minus cos 2x. Actually, this is very simple, right? First, you can rearrange like this, okay? 1 minus cos squared 2 sin x divided by, I write here half angle formula with sine, okay? 1 minus 2 sine squared x, okay? Whatever these two cancel, right? Then limit x goes to 0. Anyway, you know that 1 minus cos squared means sine squared 2 sin x, right? And divided by here 2 sine squared x, okay? Now you better put a substitution, right? Let t equals 2 sin x. T equals 2 sin x, right? Then you can see that as x goes to 0, sin 0, 0 into 2 anyway 0, then t goes to 0, right? Now you can see that limit t goes to 0, right? Then sine squared t, and I'll write here 2 sin x for the squared, then t squared into 2 actually, right? See whether you can understand or not. The final answer is 2, right? Who got 2? Okay. Right, I don't discuss this one completely until the last point because you can manage. I should help you to think only, right? So what you can do actually here, latent, right? T equals sine inverse x. Clear? If t equals sine inverse x, so you know that therefore x equals sine t. Clear? By the knowledge of inverse, then you know that as x goes to 1 over root 2, right? So t goes to where? If x is 1 over root 2, right? Sine inverse 1 over root 2 is what? Pi by 4. Okay? T goes to pi by 4, right? Therefore, you can write limit t goes to pi by 4, right? Then x means actually sine t minus cos t divided by 1 minus tan t. Tan t, okay, right? Sine t minus cos t 1 minus tan t, right? I think you can manage now, right? Write down sine by tan as sine over cos, then you can get the answer. Clear? Right, okay, then have your break, right? Then get ready after 1 hour. Clear, right? We do further coupling forces, right? Please copy down this and leave the group, leave the meeting, right? Abhiram, can you hear me?
Yes, sir.
Right, okay, then actually in coupling forces, today we have to go for the equation of the line of action also, clear, right? Then especially moments and its application part, right, will be finished. Clear, right? Moments and its application, right? Then we have to go especially for the couple, right? Force couple, right? And the applications. Clear, right? Anyway, if you can remember, I gave, right? I gave some questions in the page number 13, right? To find the line of action, right? Especially, okay, I will go to this question especially, right? Seventh one. Look at the seventh question, right? In the seventh question, right? See whether you have done this question or not, right? You are given that the sides of the equilateral triangle ABCD is 2A, right? Then I'll take the equilateral triangle like this, right? A, B, and C. Clear? Then this is the question number 7, page 13. Okay, page 13, right? Now, D, E, F are the midpoints of the sides BC, right? D, E, F, right? Yeah, anyway, it doesn't matter whatever, right? D, and here E, and here F, right? BC, then CA and AB, right? Then forces of magnitude 8 newtons along BC, right? 8 newtons along BC, right? Then 1, 2, 3, 4. BC, then CD, right? Mhm. 1, 2, 3, 4, 5. AD, AD this way. and BE this way, and EF this way. Clear? Then 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, right? 8 newtons this way, and along CD another 4 newtons, no? Right? BC, CD, right? Actually, we could have given BC as 4 Newton, that will also better, right? Then 8 root 3, right? 8 root 3 along AD, right? This way 8 root 3, right? Then 4 root 3 along BE, right? And 4 newtons along EF, right? Now, we want to find the magnitude, direction, and the line of action of the resultant. Clear? Actually, in a particular system like this, right? When you're going to find out the line of action of the resultant, right? You can take the diagram either this way or A top A B C like this. Clear? In this diagram, after drawing, right, we can see that if A were top and BC were horizontal, that also good. But anyway, right, we can manage the question by whatever way, because we are not given that take A top and BC horizontal, not like that, no? Clear? Right, now we want to find out the magnitude direction, right? See, when you go to the algebraic sum of the horizontal components, right? You know that by algebraic sum of the horizontal components, you will be having, right? Here, this angle 60, this angle 60. Clear? Now, this is 4 cos 60, right? And you know that this way minus 8 cos 60, right? And again, for this way, no, right? You can take the line of action of 4 Newton here. Actually, if you want to take this 4 Newton's point of action here, this component again plus 4 cos 60. Clear? Now, here 8 to 3, this angle 30, right? Plus 8 to 3 cos 30. Clear? 8 to 3 cos 30, and here 4 root 3, right? Then minus actually 4 root 3 cos 30. Okay. Now when you simplify, what happened? These three cancel, no? Then you will be having 8 root 3 minus 4 root 3, 4 root 3, no? Then 4 root 3 into root 3 over 2, right? Then 2's into 1 and 2's into 2, you will be having 6 Newton. Okay. When you go to take the algebraic sum of the vertical components, right? So you will be having just take that point of action of 8 Newton here, then 8 cos 30, right? 8 cos 30, actually 4 in the opposite direction, then 4 cos 30 minus, right? 4 cos 30, and then here 8 root 3 this way. Shall we take this 8 root 3 point of action here? Then this angle 30, this angle 60, then 8 root 3 cos 60, right? Plus 8 root 3 cos 60, right? And here 4 cos 30 minus, right? 4 cos 30, right? Then minus 4 cos 30, 8 root 3 cos 60, then 4 root 3 cos 60, right? Yes. These all are involved in 1, 2, 3, 4, 5. 1, 2, 3, 4, but still 1 force is not there, right? 8 root 3 cos 30, 4 cos 30, 2, 3 cos 60, yeah, right. 4 root 3 cos 60, right? That also plus, no? 4 root 3 cos 60, okay? Now you can see that when you simplify uh, focus 30, right? These two again, against of this. That's why cancel. Clear? Right? 8 root 3 cos 60 and plus 4 root 3 cos 60 means, right? 12 root 3 cos 60. No? Then you can see that actually 6 into 3, right? Then you will be having uh, yeah, 12 root 3 into root 3 over 2, right? Then 6 into 3, right? 18 newtons, right? 18 newtons, right? 8 root 3, 12, 6 into 3, 18. Yes, 18 newtons. Okay. Now, they are asking find the magnitude and direction of and line of action, right? So therefore, you can mark, right, like this. Now, I'll take this as alpha. This is x. This is y. Now, can you remember? Now, anyway, can you understand here, right? Because this length is 6. This length is 18. Actually, thrice of this length. Clear? Now, just try to make the rough sketch, but anyway, proportional to the length. Clear? Right? Then you know that R magnitude is, right, 6 square plus 18 square root, right? Actually 6 comes out because here 6 into 3, right? This is 6 into 3, right? 18, then 6 comes out, 3 square 9 plus 1 10, right? 6 root 10, right? Okay, then direction, actually tan alpha equals, right? Tan alpha equals 18 over 6. So alpha equals tan inverse 3, right? You can keep the angle like that, right? Then we want to find out the line of action of the resultant, right? Yes, that also okay, because this length is 2 meters, right? Now I will consider general principle of moments, right? Indura, can you hear me?
Sir,
Yeah. Can you tell me the general principle of moments? What is the general principle of moments? Is it hard? Attention.
sir, can't remember the definition, sir.
Hey,
Do you guys
ah, hold on.
Excuse me, sir.
Yes.
Sir, the why, I mean the thing which you did behind, sir. Why is it 18 there? So cos 16, sir. So half means.
Yes, correct. Good. Good, right. Then cos 60, no, not 30, right? Then actually, how did I take that 6, 30, 30? How did I see this 30 again and again, right? That's the thing, right? Then you will be having 6 root 3, right? Then here 6 root 3 square, right? Very nice, no? Then you will be having simply 12, right? Modulus of this one is 12, this one is root 3, then alpha equals 60, right? Wow, right? It comes nice, right? Then right, what is the definition of the general principle of moments, Rahul? What is general principle of moments?
So the resultant into the point of action is equal to the moment created by all the other forces around the point.
Arkam Abdullah, what is the definition of the what are the general principle moments? Actually, it's not a big definition, right? I'm asking the general principle moments.
Moment by resultant about a point is equal to the moment by each other forces.
Abhiram, what is general principle of moments?
In a system of coplanar forces, the moment by the resultant about a point is equal to the algebraic sum of the moments about the same point.
Ahmad Larif, what is the general principle of moments? Khalana, what is the general principle of moments?
So the moment of resultant about a point is equal to the sum of the individual moments of the forces.
Nirosh Marul, what is the general principle of moments? Not just to read out the things in the note, you just say by your right. මේ ප්‍රශ්නයක් ආපම ඔයගොල්ලන්ට උත්තරේ දී ගන්නත් පුළුවන් වෙන්න ඕන. හරි? David Denagon, what is general principle of moments? දැන් මම ලාස්ට් වීක් එකේ කිව්වා මේක මෙමරයිස් කරන්න කියලා. ඔයාලට මෙමරයිස් කරගන්න බැයි නම් කොහේ හරි හැමතැනම කමන්නේ පේන තැනක ගහන්න කියලා. හරි? දැන් මේකේ මැත්ස් වල මෙමරයිස් කරන්න ගොඩක් දේවල් නෑ බට් අන්ඩර්ස්ටෑන්ඩ් කරන්න තියෙන්නේ. රයිට්? ඒතර කියපු දේ හරියට අන්ඩර්ස්ටෑන්ඩ් කරා නම් මෙමරි එකක් නැතුව නිකම්ම මේ වර්ඩ්ස් එක තමන්ගේ මයින්ඩ් එකෙන් එනවා. රයිට්? එතකොට තාම අපි ගොඩක් ක්වෙස්චන්ස් කරේ නෑ. රයිට්? කරපු ක්වෙස්චන්ස් ටික ප්‍රැක්ටිස් කරන්න තිබ්බා මේ වීක් එක ඇතුළත. රයිට්? කරපු ක්වෙස්චන්ස් ටික ප්‍රැක්ටිස් කරා නම් රයිට් මේ මොමන්ට් බයි රිසල්ටන්ට් ඉක්වල් මොමන්ට් බයි ඊච් ෆෝස් කියලා හරියන්නේ නැහැ රයිට් කියපු හැම වර්ඩ් එකකම රයිට් කියපු හැමෝම කොහේ හරි පොයින්ට් එක ඩිෆෙක්ට් එකක් අතෝ කිව්වේ ඕගොල්ලන්ට මම ඔය එහෙම කියලා නැහැ රයිට් මම කියපු definition එක ඇතුළේ හැමතැනම තියෙනවා හැම වචනයක් මොන ඒවා ටික. හරි? algebraic sum of the moment by each force කියලා වැඩක් නැහැ. algebraic sum of the moments by each force about the same point කියන්න ඕන. right? එතන moment by resultant equal moment by each force කියලා හරියන්නේත් නැහැ. moment by resultant about a point. ඒ ගන්න point එක important. ඒ point එක වටේ තමයි moments equal වෙන්නේ resultant එකේ අනිත් කට්ටිය එකද. right? එතන algebraic කියවෙන්න ඕන plus the minus the ගන්න කෙනෙක් කියවෙන්නකො. හරි? එතන මේ maths වල definition එකක් දෙනකොට හැම word එකකම meaning එකක් තියෙනවා. right? general principle of moments කියන idea එක නැතුව center of gravity එක manage කරගන්න එහෙමෙන් ගණන් හදන්න පුළුවන්. මම කියන්නේ meaning එකක් ඇතුව කරන්න බෑ. right? ඒක තමුන් දැනගන්න ඕනේ තමුන්ගේ self discipline එකක් තියාගන්න මේක practice කරන්න. right? මේක මේ දැන් මෙහෙම ඕගොල්ලන්ට මේක maths බෑ කියලා කියන ඕගොල්ලන්ට chemistry කොහොමද දරුව යනවනේ. right? chemistry වල තියෙනවානේ කොහොමද ගොඩක් දේවල් memorize කරන්න. right? organic chemistry වලට ගිහුවාම memorize කරන්න බෑ ගොඩක් දේවල් තියෙන්නේ. right? ඒක කොහොමද කරන්නේ එතකොට? inorganic chemistry වලට ගිහුවාම memorize කරන්න ගොඩක් දේවල් තියෙනවානේ. right? ඉතින් දැන් මේ chemistry maths physics නේ කරන්නේ majority එක. right? එතන දැන් physics වල 100% මේ understanding කරලා කරන්න දෙයක් නැහැ නේ. right? ඒකෙත් තියෙනවා memorize කරන්න formula. මොකද මේ physics වල හැම එකම mathematically prove කරන්නේ නැහැ නේ. මොකද bio කරන කට්ටිය physics කරන හින්දා ඒගොල්ලන්ට මේ prove කරගන්න බෑ හැම එකක්ම. right? Hooke's law එක prove කරන්නේ නැහැ. Hooke's law එක application කෙලින්ම තියෙන්නේ. right? Lawi's theorem එක ඔය මුල් හරිය prove කරන්න ඇති. right? මේ නිකම් ස්ටඩි කරනවා කියලා මේ ස්ක්‍රීන් එකක් ඉස්සරහ විතරක් ඉන්න එපා ඉතින්. right? මම ෆිසිකල් ක්ලාස් එක නම් අනිවාර්යෙන් 4-5 දෙනෙකුට දීලා. right? සමුදේ මේ නිකම් මේ ඇවිල්ලා එහෙම වැඩක් නැහැ කියලා නිදා ගන්නවා. right? ඔන්ලයින් එකේ ඉන්නවා කියලා. එහෙම ඉන්න ඕනේ නැහැ නේ. right? හොඳම දේ පාඩුවේ නිදා ගන්න එක ටාගට් එකක් තියාගන්න නැත්නම් මේ ටයිම් එකේ එක්ස්ට්‍රා කරකියුල කරලා මට ස්ටඩිස් අප්සෙට් ගියා. එහෙම කියන කට්ටියට මේක තරම් chance එකක් තවත් නැහැ. right? එක්ස්ට්‍රා කරකියුල කරන්නේ නැතුව දැන් හොඳට ස්ටඩිස් වල ફોකස් කරන්න පුළුවන්. right? එහෙනම් මේ ටයිම් එක කියන්නේ මාර ටයිම් එකක්. වැඩ කරන එකට. right? opportunities ඕන තරම් තියෙනවා. ඔන්ලයින් එක ඇත්තටම සුපර් මේ තනිකර ફોකස් කරන්න පුළුවන් නම් ස්ටඩිස් වලට. right? අර පොඩි අවුලක් තියෙනවා කනෙක්ෂන් අවුල් තියෙනවා ලංකාවේ. right? අර මේ face to face meet වෙලා පොඩි discussion කරන්න opportunity එකක් නැහැ. ඒක තමයි මම මේ try කරන්න පුළුවන් තරම්. right? ඔය අනිත් මිනිස්සු වගේ නිකම්ම මේක මේ කියවන්න නැතුව discussion එකකින් යන්න. right? මම ඔය කියන්නේ නැහැ. ඔයාලා කැමති මං කියන්නේ නැහැ. ඔයගොල්ලෝ අහගෙන ඉන්නවා. ඒකට හරි කැමති. right? හැබැයි ඔළුවට දෙයක් ගන්න නැත්නම් තේරුමක් තියෙනවා. අර ඇත්තටම මේ මීටින් එක කට් කරලා right? මේ මීටින් එක කට් කරලා නිදා ගන්න හිතුණා. හරි? මම ඊළඟ දවසේ අහනකොට අනිවාර්යෙන් හැමෝම අන්මියුට් කරලා උත්තරේ කියන්න පුළුවන් වෙන්න ඕන. හරි? මොකද මේක මේ ජෙනරල් ප්‍රින්සිපල් ඔෆ් මොමන්ට්ස් කියන එක ඒක ඉම්පෝටන්ට්. right? මොකද මොමන්ට්ස් ගන්න හැමදාම තියෙනවා. right? okay then anyway right now then by general principle of moments right we want to go to the we want to go to find out the line of action right by general principle of moments then moment about a right moment about a by r equals moment about a by each force right then moment about a by r means the y component is actually 6 row 3 then 6 row 3 into I got this length as simple L right L equals 6 row 3 into L right equals moment by each force. That means now actually you know that these two are on the same line. So you just take their resultant quickly because we don't need to take moment by 4 and 8 separately. Right? Here 8 minus 4 is anyway 4. Right? Just take the line of action here. Right? Then if you take the line of action here and if you take the point of action here. Right? If you take the point of action here, right, this angle is 30, right? Then 4 cos 30 has a distance. 4 cos 60 passes through A, right? So I will write 4 cos 30, right? 4 cos 30 into, right? 4 cos 30 into, the distance is 2A, right? That moment, see whether the arrow is this way means actually it's an anti-clockwise sense moment, so plus, right? Now, you know that the line of action of A through 3 passes through A, right? No moment by A through 3. That is the only force not involved in for the moments, right? Then when you go for this 4 root 3, we have a small, actually we have a quicker technique, right? You know that it's an equilateral triangle. This is the midpoint means here 90. So this length is A. So we can take quickly then plus 4 root 3, right? 4 root 3 into A, right? 4 root 3 into A, right? Then if you go for this new 4 newtons, right? Actually, that's the only other force involved for the moments, right? Actually, by this 4 Newton, you can take point of action here, right? This angle 60, this angle 30, no? Then 4 cos 30 perpendicular, right? 4 cos 60 passes through A. Then 4 cos 30 sine minus. Then 4 cos 30, right? 4 cos 30 into, right? 4 cos 30 into here A, right? Then you know that root 3 is there in each and every term, right? So you can divide all by, right? You can divide all by if you plan by 2 root 3 because here you know that cancel 2 root 3, right? Then all are divisible by 2 root 3, right? Then here 2, right? And you know that cos 30 and here 2, right? Then actually here 3, okay? Then you will be having 3L equals, right? 3L equals here 2A and plus 2A altogether 4A minus A 3A, right? Therefore L equals A, right? L equals A, right? We found the line of action actually resultant, right? Cast the line AB at a distance simple A from A. That means actually F, right? Then you can see that therefore, right? R resultant is a force, right? R passes, right? Passes through, right? F. You can say like that. Who got this answer like this? Check each and every point. Anyway, copy down. Yeah, even you can take the moment about B also because if you take the moment about B, two forces cancel, that's all, right? Only one extra force which is not passes, yeah, which is not involved in for the moments, right? It doesn't matter whatever point, that's why I told that a particular point, right? You have to mention the point carefully, right? Yeah, lastly also we discussed up to a hexagon, I think, right? Am I correct, Sarah? The last example is hexagon, right? Regular hexagon in the note. Kavish, can you check the last note, last example?
We did the hexagon one and a rectangle one. Last we did was a rectangle.
Only rectangle, right?
So we did one hexagon question also.
By the application of the uh, uh, actually general principle moments, we discussed hexagon also, no?
Yes, sir.
Yeah, okay. Right. Okay. Then the method is always same. Clear, right? When you want to find out the line of action, right? You have to actually when you want to find out the resultant and line of action, you will have to find the algebraic sum of the horizontal components, the algebraic sum of the vertical components, then magnitude and direction of the resultant because they ask in the resultant. Clear? If they don't ask the resultant and if they ask the line of action only, actually you can understand very simple, right? We need to find out only the vertical algebraic sum of the vertical components. Clear? After finding algebraic sum of the vertical components, right, you can find out the line of action very easily by general principle of moments, right? But in these questions, right, we are given mostly find the resultant and line of action. So because of that, we have to find algebraic sum of the horizontal and vertical components, right? Right. Especially දැන් ඔයගොල්ලෝ අතර මේකදී පාවා ඩිෆෙක්ට් එකක් ආවා කියලා කියන්නේ ජෙනරල් ප්‍රින්සිපල් ඔෆ් මොමන්ට්ස් රයිට් මම හිතනවා ඒක ඉස්සරහදී ඒ විදිහටම තියෙන්නේ නැති වෙයි කියලා. හරි. මම එක්ස්පෙක්ට් කරනවා ගෙදරදී ප්‍රැක්ටිස් කරලා ටිකක් මේක කන්ටිනියුවස්ලි කරයි කියලා. හරි. දැන් මම හිතන්නේ last Monday right මම ඔය ජොයින් කරගත්තා ඔයාලට right දැන් මම විතරක් නෙවෙයි ඇත්තටම හරි තව මේ এডুকেෂන් ෆීල්ඩ් එකේ ඉතින් ඇත්තටම টপ කැරක්ටර් එකක් තමයි ඒ ප්‍රොෆෙසර් පිටවල හරි ඉතින් එයාගේ තේ සෙෂන් එකේ ඔයාලට ඉම්පෝටන්ට් පාර්ට්ස් සෑහෙන්න ඇති හැම එකක්ම අපිට ඉම්පෝටන්ට් වෙන්නේ නැති වෙයි ඕනම දෙයකදී ඕනම දේ කෙනෙක් කියන ඕනම දෙයක් අපිට සීරීස් එකක් ඕන වෙන්නේ නැති වෙයි හරි අපිට සෑහෙන ප්‍රමාණයක් ඕන වෙන දේවල් තියෙනවා හරි so please raise your hand those who attended to the last Monday session. Yeah, I think yeah, right. Most of you attended, right? Therefore, ඒකේදී ඔයාලට පේන්න ඇති data past may recently, right? Past years 2019, 2018, and 2017, right? Years wala university entrance and the opportunities for the A-level math students, right? So if you check that the bar graphs, right, you could see that, right? Math students are the ones having the biggest opportunities compared to all the other streams, right? Arts, no need to talk, right? Commerce and bio. Even math students are having that opportunities than biology students also. Okay, right? ඒ හින්දා ඇත්තටම මේ opportunity එක ඇත්තටම ගන්න ඒකයි කියන්නේ වැඩ කරලා right minimum qualification and ඊට පස්සේ තියෙන levels right මම කියන්නේ minimum qualification ගන්න කියලා. එහෙම ගත්ත කෙනාටත් තියෙන opportunities ඔයගොල්ලන්ට පේන්නේ නැති. හරි. මම plan කරන්නේ මගේ part එක ඉවර කරලා maximum gain. හරි. මේකෙදී ඔයාලා දුන්න තියෙන එක. මේ examples ආය rough papers වල practice කරන එක right sometimes 3-4 times practice කරන එක right ඊට පස්සේ තව extra questions කරන එක speed එක improve කරන එක right ඒ ඔක්කොම තමුන් තනියෙන් දෙන game එකක් right ඒ හින්දා ඔය රෑන්ක් එක කියන එක කම්ප්ලීට්ලි ඩිසයිඩ් වෙන්නේ කවුරුත් හින්දා නෙවෙයි තමුන්ගේ මේන් ඉෆෙක්ට් එකකින් හින්දා රයිට් මට පුළුවන් හැමෝම ෆේල් නොකර පාස් කරන්න හරි එතකොට මගේ මං ඒ කරන process එකේ හැටියට ඊට පස්සේ තම තමුන්ගේ plan එකට right individually එක එක්කෙනා right තමුන්ගේ plan එකට target එකට වැඩ කරන්නත් එක තමයි success වෙන්නේ right especially ඔයාලට තියෙන opportunities දැන් වැඩි හරි තාමත් මේ online එකේ කොහේ හරි තැනක නිකන් ඇඳකවත් දිගා වෙලා හරි එහෙම නැත්නම් ඔය වාඩි වෙලා නිකන් කුදු ගහලා හරි නිකන් ඔය නිකන් මේක දිහා බලන් TV screen එකක් වගේ ඉන්නවනම් ඉන්න එපා right එහෙනම් please මොකද මේක effective වෙන්නේ නැහැ right please right you should have a proper working table right එතකොට එතන ඒ study කරන table එකේ right ඔයාලගේ device එක laptop එක හරි මොකක් හරි smartphone එක හරි ඒක හරියට point එක තියාගන්න පුළුවන් වෙන්න right book එකත් එක්කලා ගමුන්ට comfortably like ඉස්සර නම් physical classes වල සමහරට pack වෙලා ඉන්න වෙන්නේ right එතකොට අමාරුයි right සමහර විටක දාඩිය දවල්ට වැස්ස කාලට පොඩ්ඩක් එහෙමෙන් අප්සෙට් යන්න පුළුවන්. එහෙම කිසිම ඔයගලන්ට ප්‍රොබ්ලම් එකක් නැහැ. ඔයාලගේ ගෙදර ඔයාලගේ කම්ෆර්ටබල් ඒරියා එකක් හදාගන්න පුළුවන්. right? කම්ෆර්ටබල් ප්ලේස් එකක් තියාගන්න පුළුවන්. right? කිසිම ඩිස්ටර්බ් එකක් නැති විදිහට තියාගන්න පුළුවන්. හැබැයි මට තාමත් ඇහෙනවා සමහරු ඔය හදිසිය හරි අන්මියුට් වුණාම අවුට්සයිඩ් ගොඩක් නොයිස් එකක් තියෙනවා කියලා පේනවා. right? එහෙම ස්ටඩි කරනවා නම් කරන්න එපා මේක. ඒක ඇත්තටම ඉෆෙක්ටිව් නෑ. right? නිකන් ක්ලාසස් යනවා කියලා right video එකක් නිකන් බලන්න හිටියා කියලා මේක හරියට වැටෙන්නේ නැහැ. හරි. ඔය කියන proper instructions හරියට follow කරලා right proper discipline නැත්නම් study කරේ නැත්තම් right regular continuous study plan එකක් තිබ්බේ නැත්තම් right ඇත්තටම මේක success කරගන්න බෑ. right මම හිතන්නේ මම ඔයාලා groups වල share කරා right how much worth if you work as a team right අනේක මම Facebook එකේ දැක්ක පොඩි animation එකක් එක්කලා මම ඔයාලට share කරා right ඉතින් ඒක තමයි reality එක ඇත්තටම හරි sharing කියන එක important right දන්න කෙනෙක්ගෙන් මොනවද අහගන්න එක ඒක important right දන්න කෙනෙක් කාට හරි කියලා දෙන එක ඒක important මම හිතන්නේ මම කියපු ගොඩක් දේවල් ප්‍රොෆෙසර් පිටවලත් කිව්වා හරි මොකද අපි ඔක්කොම education field එකේදී අපි ගත්ත experience හින්දා right ඇත්තටම දැන් සමහරට එයා කියපු එක point එකක් මම ගැන මම කියන්නම් ඇත්තටම හරි එකක් තමයි මේ සාමාන්‍ය responsibility එකක් හොඳට ගන්න පුළුවන් කෙනෙක් කියලා කිව්ව එක. ඇත්තටම ඒක මම ගැනත් මම හොඳට දන්න කෙනෙක්. හරි. මොකද මම ස්කූල් ලයිෆ් එකෙත් ගොඩක් වෙලාවට පොඩි කාලේ ඉඳන්ම ක්ලාස් මොනිටර්, ස්කූල් හෙඩ් ප්‍රිෆෙක්ට් මම ගියපු හැම රයිට් ඔයාලා දන්නවා මම ස්කූල්ස් විදියට ගත්තාම රයිට් ප්‍රාථමික ඉස්කෝලේකට ගියා. ප්‍රයිමරි එක නෙමෙයි නිකන් අපි ගත්තොත් අපි ඒවට කියන්නේ grade 1 to 5 වගේ තියෙන ස්කූල් එක. හරි. ඒ ටයිප් එකට ගියා. ඊට පස්සේ මහාවිද්‍යාලයකට ගියා. सेंट्रल कॉलेज मध्य महाविद्यालय पिन्नवल ඊට පස්සේ මම ටෙක්නිකල් කොලෙජ් ගියා රයිට් ඊට පස්සේ මම යුනිවර්සිටි ගියා. ඒතර ගවර්න්මන්ට් එකෙන් මේන්ටේන් වෙන්න ඕනේ හැම এডুকেෂන් ඉන්ස්ටිටියුට් එකක මම එක්ස්පීරියන්ස් අරන් තියෙනවා රයිට් ඊට පස්සේ මම ට්‍රේනින් ටීච් කරා ප්‍රයිවට් ස්කූල් එකක් විදිහට CIS ටීච් කරා ඉන්ටර්නැෂනල් ස්කූල් එකක් විදිහට රයිට් ඒතර මම මේ කියන්න හදන්නේ මේ හැම එකේදීම කරන කාලේ හරි ස්පෙෂලිම මම ස්කූල් ලයිෆ් එකේදී යුනිවර්සිටි යනකොට බැච් එකේ ඇසිස්ටන්ට් රෙප්‍රසන්ටේටිව් රයිට් එතකොට ඔය ගොඩක් ඒවා ඇත්තට මම ට්‍රේන්ඩ් මුල්ම කාලේ ජොයින් වෙච්ච ගාම ස්ටාෆ් එකේ ඇත්තටම මට ඔය එක පෝස්ට් එකකුත් හම්බෙනවා හරි ඒ දුන්න හැම දෙයක්ම මම රෙස්පොන්සිබිලිටි එකක් මම කම්ප්ලීට් කරලා තියෙනවා රයිට් ඒකයි මම එයා ප්‍රැක්ටිකලි දන්නවා මම සමහර ඔය ඔයාලා දන්නා යුනිවර්සිටි එකේ අපි අඳුරගත්ත එක්ස්ප්ලෝරර්ස් ක්ලබ් එකේ ඒතකොට එක්ස්ප්ලෝරර්ස් ක්ලබ් එකේදී එක්ස්ප්ලෝරර්ස් ක්ලබ් එකේදී ගොඩක් වෙලාවට හොයන්නේ soft skills right leadership qualities right planning organizing ඔය කියන දේවල්. හරි ඔයාලා මේ හිතන්න බෑ ඔයගොල්ලෝ නැති දේවල් කියලා. හැමෝම ගාව මේ තියෙන දේවල්. හැබැයි හැමෝම මේක හරියට පාවිච්චි කරන්නේ නැති දේවල් ඕවා. හරි. ඒ හින්දා අපි මට දුන්න සමහර responsibilities මම හොඳට complete කරා කියලා එයක් දන්න පුද්ගලයා. හරි. ඒතර ඒකයි මම කියන්නේ මේකෙදිත්. හරි. දැන් මේකෙදිත් මම මේ field එකට එනකොට මට කලින් maths professor කෙනෙක් teach කරේ. right. එයා නැද්දි තමයි ඔක්කොම ළමයි මගේ මුලින්ම ක්ලාසස් ආවේ. හරි. ඇතරම මේ ඒකට මේන් රීසන් එක තමයි. හරි. සිලබස් එක හිටපු අය කවුරුත් මට කලින් හිටපු ගොඩක් අය සිලබස් එක ඉන් ටයිම් කවර් කරේ නැහැ. රයිට්. ඒක රෙස්පොන්සිබිලිටි එකක් විදිහට ගත්තේ නැහැ ඒකයි. හරි. දැන් ඔයාලා පර්සනලි දන්නවා මම හැම තර්ස්ඩේ එකක්ම සැක්‍රිෆයිස් කරනවා මෙතන. හරි. එතකොට එහෙම කැපකිරීමක් කරන්න හැමෝටම බෑ. හරි. ඉතින් දැන් ඔයාලා ඒ ට්‍රස්ට් එක මං ගැන තියලා තියෙන්නේ මං ඒක කරපු නිසා. හරි. ඒතර මම මගේ පාර්ට් එක හරියට කරනකොට ඕගොල්ලන් පාර්ට් එක නොකර ඉන්න බෑ. මොකද ඔයාලටත් ඔය කියන qualities ඔක්කොම develop කරන්න අනිවාර්යයෙන්ම මේ important time period එක. right? එහෙනම් තමුන්ගේ අනිත් වැඩ කරන ගමන් ෆන් එකේ ඉන්න ගමන් අනිත් හැම දෙයක්ම කරන ගමන් මේ පාර්ට් එකත් completely කරන්න ඕනමයි. හරි? මොකද තමුන්ට ලැබෙන responsibility එක තමුන් හරියට complete කරොත් තමයි තමුන් ගැන trust එක වැඩි වෙන්නේ. right? example එකක් විතර ඔයාලගේ parents ලා මොනවා හරි පාටි එකකට හරි මොනවා හරි දැන් නෑ ඉස්සරහට හරි කලින් හරි. ඒ පාටි එකට ඔයාලා අවුලක් නැතුව යවන්නේ. right? ඔයාලගේ trust එක තිබ්බොත්. right? එහෙම නැති වුණොත් ඒ parents වලට ඔයාලා ආයෙ ඊට පස්සේ එහෙම පාටි එකකට යවන්න බැරුව යනවා. right? ඒතර අපි අපේ life එකේ හැම වෙලාවෙම trust එක කියන එක important. ඒතකොට අපිටත් stress එකක් නැහැ. right? ඉතින් අපි හැම වෙලාවෙම අපි කෙනෙක් අපි ගැන තියෙන trust එක ඒක රකින්න වෙනවා. right? දැන් මම expect කරන්නේ මොකද්ද? ඕගොල්ලෝ මේ O levels කරලා right? හොඳම results දාලා මෙතෙන්ට A level ආවොහම ඒ capacity නැති කට්ටිය නෙවෙයි. ඒතර capacity එක තියාගෙන right? අර මම කියන soft skills ටික නැත්තම් තමයි failures ලා වෙන්නේ. right? ඒතකොට මේ failures ලා වෙන්න main reason එක soft skills කියන එක නැත්තම් තමුගේ හරි proper planning, imagination, targeting right? ඔය දේවල් ටික හදාගත්තේ නැත්තම් right? ඊට පස්සේ ඉතින් මේ unsuccess. right? ඒක පළවෙනි දේ තමයි right? ඔන්න ඔය කියන ඒවත් හදාගන්න එක. right? එහෙනම් මේක අතරම මම ඔය ඇඩ්වෙන්චර් ස්පෝර්ට්ස් කරද්දි මම ගත්ත එක්ස්පීරියන්ස් කීපයක් පස්සේ කියන්න. අද මට ඇත්තටම කියන්න මෙන්ටල් ටිකක් නැහැ. ආද ඔයාලට පොඩි ඇත්තට මේ ඇඩ්වෙන්චර් ස්පෝර්ට්ස් වලදී මම කරපු ගත්ත එක්ස්පීරියන්ස් එක ඇත්තටම කියන්න හිටියේ. මටත් ඕගොල්ලන්ගේ දුන්න උත්තර ඇත්තටම සැටිස් නෑ. හරි. ඉතින් එතකොට පොඩ්ඩක් මටත් ටිකක් මෙන්ටල් ටික හදාගන්න. ඔයාලා මම කරන කියන දේවල් මේ දෙන දේවල් ඔක්කොම 100% කරනකොට ළමයි මට මාර thrill right? the example එකක් විදිහට 2016 batch එකේ right? ඔය යසිත්ලාගේ batch එකේ ඉන්න කාලේ මට මාර විදියට කතන්දර එන්නේ. හරි? මොකද මට පේනවා මාර්ගද වැඩ කරනවා ඒකත් එක්කලා එතකොට ළමයි මේ තවත් ගොඩක් දේවල් කතා කරන්න පුළුවන්. හරි? එතකොට මේ මෙතනදී නම් ගොඩක් ලා ඩිස්ටන්ස් හින්දා තමයි මේ කියන්න බැරි. හරි? ඒ වුණාට එහෙම මමත් මගේ ලයිෆ් එකේ ගොඩාක් එක්ස්පීරියන්ස් ගත්ත කෙනෙක්. හරි? එතකොට මම හිතන්නේ ඔය ඔයාලට මම ෂෙයා කරන්නම් වීඩියෝ එකක් ඔය මගේ මුල්ම බැච් එකේ හිටපු සමහර ගෝලියෝ අන්තිම දවසේ ක්ලාස් එක ගැන කියපු දේවල්. හරි? මේ කම්පියුටර් එකේ තියෙනවා. හරි? මොකද එහෙම මේ අපි ඇත්තටම හැම වෙලාවෙම try කරා right ඉන්න කාලය තුල පුළුවන් තරම් අපිට වඩා සීනියර් කට්ටිය ආශ්‍රය කරලා එක්ස්පීරියන්ස් ගන්න. හරි? ඒක මාර වර්ත් වුණා ලයිෆ් එකට. හරි? ඉතින් ඒ හින්දා මේ ස්ටඩීස් වලට මම ටීච් කරන්න දෙන්නේ නිකම් මැත්ස් විතරක් කරලා නෙවෙයි මගේ ලයිෆ් එකේ. හරි? හැබැයි දැන් ටීච් තමයි කරන්නේ. හරි? මොකද සමහර දවස් මට තියෙනවා දැන් වෙන්ස්ඩේ ගත්තාම right උදේ මම හිතන්නේ මේ කැපකිරීම ගොඩක් අය කරන්න අමාරුයි. හරි? උදේ 7 ඉඳලා right රාය 10 වෙනකම් මට එක දිගට ක්ලාසස් තියෙනවා. right? මුළු දවසෙම පැය දෙකමාරක් විතර මම ෆ්‍රී. right? ඒතර එහෙමයි අපි වැඩ කරන්නේ. හරි? ඒ හින්දා මේ මම කියන්නේ දැන් ඔයාලට මේ අවුරුදු දෙකමාරක් විතරයි තමයි මේ Thursday මේ ටයිම් එක Friday අර ටයිම් එක සැක්‍රිෆයිස් කරන්න තියෙන්නේ. right? මම ලයිෆ් එකේ හැමදාම දැන් 2023 ටයිම් ඉන්ටර්වල් එක ගත්තොත් අපි ඒක හැමදාම කරනවානේ. right? ඒ කැපකිරීම කොච්චරද කියලා ඔයාලා හිතන්නේ. හරි? ඒකට පළවෙනි දේ තමයි ඔයගොල්ලෝ ගෙදරදී ඒ කියන්නේ තනිකර හෝම්වර්ක් කරලා ප්‍රිපෙයාර් වෙලා right ලෙසන් එකට ඇවිල්ලා වාඩි වෙලා රෙඩි වෙලා ඉන්නේ. right? Thursday 3 o'clock වගේ වෙනකොට right 2:45 3 වගේ වෙනකොට හරි අනිවාර්යයෙන්ම ලෙසන් එකට ප්‍රිපෙයාර් වෙන්න කලින් 2 වෙනකොටවත් ඔයගොල්ලෝ රෙඩි වෙලා ඉන්න ඕන. right 2 o'clock වෙනකොට last week එකේ note එක බලන්න පුළුවන් වෙන්න ඕන. traveling time waste එකක් නැහැ. වෙන කිසිම දෙයකට waste එකක් නැහැ. ඇඳුමක් අඳින්නවත් time waste වෙන්නේ නැහැ. right? ඇඳුම් නැතුව ඉන්න එපා. හරි? but ඒතර තේරුම් ගන්න right at least 45 minutes 1 hour කෙලින්ම ප්‍රිපෙයාර් කරලා තියාගන්න පුළුවන්. ඒ කියන්නේ last week එක කරපු දේවල් ස්ටඩි කරලා ප්‍රිපෙයාර් වෙලා ඉන්න පුළුවන් ඊළඟ ලෙසන් එක කන්ටිනියු කරන්න. right? මේ චේන් එක ඒ විදිහට ගෙනිච්ච නැත්නම් ඔයාලට මේ ඇත්තටම කම්ප්ලීට් කරන්න අමාරු හරියට. right? ඉතින් ඕගොල්ලන්ගේ පැත්තෙනුත් ලොක් ගේම් එකක් තියෙනවා. මම දැකලා තියෙනවා. මුලින් කස් තිරන් ඇටලා උඩ පැනලා එළල් පටන් ගත්තට right මැද්දට යනකොට ගොඩක් කට්ටියට මහන්සි වැටලා එහෙම unsuccess වෙන කට්ටිය. ඒ කට්ටියට ලයිෆ් එකේ අනිත් දේවලුත් ඒ විදිහටම රෙස්පොන්ස් කරන්න අමාරු ගොඩක් දේවල් එතකොට. හරි. එහෙනම් මේක මුලින් ඉඳන් අගට යනකම් ඒ ටාගට් එක තියාගන්න පුළුවන් කට්ටිය වෙන්න ඕන. මොකද මම හොඳට දැකලා තියෙන මුල් කාලේ ඔය සමහර ඒවාට නිකන් ලොකුවට උඩ පැන්නට හරි මැදට ගියාම එහෙම හරියට කරගන්න බැරි වෙච්ච කට්ටිය මම හොඳට දැකලා තියෙනවා. ඒකට මේන් රීසන් එක තමයි වෙල් ප්ලෑන් නැති එක. හරි. එහෙනම් මේක ඉවසීමෙන් රයිට් ටාගට් කරලා කරන්න ඕන දෙයක්. හරි. ඒක හොඳට ඔළුවේ තියාගන්න. Right. Okay. Then write down another subtopic. Right. The equation of line of action. The equation of line of action. Right. Okay. Now, this part also very simple because of you are okay with the general principle of moments, right? Now, when we go to find out the equation of line of action, right, we have to only do few steps more than what we have done up to this. Okay. See, I will take one example, right? Anyway, yeah. Before we move to that, you know that we discussed coordinate geometry, right? If you are given a straight line with a gradient is 2, right, and a point is 1,3, something like this, right? I think you can find out the equation easily, no? Right? So we take a variable point on the line, right? So what do we do actually? Y minus 3 divided by x minus 1 is another way of writing the gradient. Y difference divided by x difference is another way of writing the gradient. So that gradient is equal to 2. Then you can simplify 2x minus 2 plus 3 means plus 1, right? We can take the line of actually equation of the line like this, right? Yeah, that's the only thing has to be applied additionally. Clear, right? Then now I will take, right, a system of coplanar forces, right? Now x, y. I will model a system of coplanar forces with a rectangle like this, right? Now suppose that this length is 4 meters, right? If you take actually 1 meter as 1 unit, right? You can take this coordinate as 4,0, no? I'll take this height is 3 meters, right? Then actually, you know that this point, right? I'll take O, A, B, and C here. Clear? Then especially this coordinate 4,3, right? Then the point C, this coordinate is 0,3. Clear? Now, if you extend, actually, if you join these lines, right? Now, suppose that we have, right, a system of coplanar forces like this, right? This way, 10 newtons, right? Okay, 10 newtons, right? And this way, 20 newtons, right? 20 newtons, right? And here, actually, 8 newtons, right? And this way, right? Suppose that 6 Newton, clear? Now, you are given a system of coplanar forces. We want to find out the resultant and equation of line of action of the resultant, clear, right? Now, that's very simple, right? How do we do? You know that definitely this force inclination has to be mentioned, right? So you know that here tan theta equals actually 3 over 4. Then I will write quickly sin theta is 3 over 5 and cos theta equals 4 over 5. Because you know that in a triangle, right? If this theta 3, 4 means this is 5, that's why. Clear? Right. Then you got when you got that, I give some of the horizontal components, right? So you will be having there are 20 cos theta, right? 20 cos theta minus 10 cos theta. Clear? 20 cos theta minus 10 cos theta and minus 8, right? Then see actually here 10 cos theta, right? Cos theta means actually 4 over 5. So it's nicely cancelled, no? Right? 10 into 4 over 5 minus 8 means, right? Actually x is 0, clear? X is 0, right? When you take the ideal sum of the vertical components, right? Then you can see that, right? 10 sine theta, right? 20 sine theta plus 10 sine theta, right? And minus 6. Anyway, you know that here 10 sine theta, right? 10 sine theta means see 3 over 5. This and this cancel, no? Right? So you will be having, right? Here 3 over 5 means 12, right? Actually, the resultant is vertical. Did you see? X is 0, right? Y is 12, right? Therefore, R magnitude also 12, right? And you can write R is vertical, right? You can say in words like that, resultant is vertical direction, right? Now we want to find out the line of action, right? Then in this case, it's very easy, no? Right? This is the line of action of the resultant, right? I'll take this as x, okay, right? Then by general principle of moments, right? Moment about O by R, right? Equals moment about O by each force, right? Moment about O by each force, right? So therefore, resultant is 12, then 12 into x, then 12 into x equals moment by each force means 10 sine theta and this cancel, right? 10 sine theta into 4 minus 6 into 4 plus 8 into 3. Okay. Then actually you can see that this is 3 over 5. Then this and this will cancel. Okay. Then in the next step 4 into 3 and 4 into 3 cancel. Okay. Therefore, x will be 2, right? Now, if I ask the equation of line of action, right, the answer directly came because why? This x coordinate is 2, 0, line is vertical means actually equation is also 2. Okay. Anyway, let's do this as a case study, right? And I will add some parts also, right? Anyway, write down. A system of coplanar forces, a system of coplanar forces a system of coplanar forces act along the sides act along the sides act along the sides given of a rectangle act along the sides given of a rectangle OABC as follows. Mark first part. Find the resultant n. Find the resultant n. Find the resultant n. Equation of line of action of the resultant. Equation of the line of action of the resultant. I am discussing few more parts related to this, but anyway, first take a clear diagram, right? Take a sufficient diagram, right? Sufficient diagram means now you have to understand how much is the sufficient, right? Especially what you have to understand, right? Take dimensions according to your own way. About ටිකක් ලොකු diagram එකක් ගන්න. හරි? Sufficient කිව්වම තේරෙනවනේ තමුන්ට ඕන size එකට. හරි? Ashok, finish. Abhiram, finish.
Yes, sir.
Right. Okay. Then I will add another one. Right. Mark the second part and write down. If an additional force of magnitude 12 Newton, okay, if, an additional force, if an additional force of magnitude 12 Newton is given to the system along OA, is given to the system along OA, if an additional force of magnitude 12 Newton is given to the system along OA, actually write down with a bracket while other forces remain same, right? While other forces, right, remain, right? Find the new resultant and the equation of line of action of the resultant. Find the new resultant and the equation of the line of action of the resultant. Find the new resultant and the equation of line of action of the resultant. Right. Okay. Now, what you have to understand, actually, if you introduce an additional force, right, here this way 12 Newton. Now you can understand very simply what happened to the system, right? Actually, earlier, by this all the forces, algebraic sum of the horizontal components is 0 means actually, right, x nu, right? Actually, new capital X, new algebraic sum of the horizontal components, earlier 0, then 0 plus 12, right? Actually 12 newtons. And you know that the force introduced is horizontal, right? So there's not an effect to the vertical component by a horizontal force. Then vertical component summation, right? Algebraic sum of the vertical components is still 12. Got it? That is still 12, right? Then what you can see actually, right? Then here this way 12 and vertically this way 12, then the resultant this way. Okay. Now R magnitude equals 12 root 2, right? 12 squared plus 12 squared square root, right? Now you should be an expert to write the answer directly like this, right? And you know that when you take tan alpha is actually 12 or 12 1, right? Therefore alpha is pi by 4, right? Tan alpha is 1. That is the most important part. Clear? Then when you go to find out the line of action of the resultant, right? Now you know that the new line of action of the resultant, right, is not this vertical one, right? If you take an inclined force like this, right? If you take this as the point of action, right? So anyway, we know that here vertical component is 12, horizontal component is 12, the length is x, okay? Then when you take, right, by general principle of moments, clear? By general principle of moments, right, moment about O by R, right, equals moment about O by each force, right? Now, I have mentioned the direction also, right? Then moment about O by R means R's vertical component 12, right? 12 into X, clear? Now, if you just thought analytically, right? What will happen? Earlier moments, same way, right? Earlier moments you will be having same way, right? But if you are going to find out the total moments, even there's not a moment by this 12 Newton, clear? So therefore, right, the simplified answer, right, earlier you got me here actually 6 and 10 sine 30, right? 10 sine 30 into 4 minus 6 into 4, right? And plus 8 into 8 into 3, okay? Still remains same because no moment by 12, right? See, right? 12 into 0, right? No need to write this part, I just showed no moment by 12, clear? That means you can see that actually these cancel, x comes as 2 meters, right? Still you can see that the line of action has not been changed, right? Line of action is not changed by the 12 Newton horizontal along OA. Okay? Now you can find that equation very easily. This is the way, understand, right? You know that this is an inclined line, right? What is the gradient of this line? Gradient means actually this angle's tan ratio. That means actually alpha is alpha here. So tan alpha is 1. That means gradient is 1. Understand this line's gradient, right, is 1. Now, very simple, right? What is the use of tan alpha equals capital Y of x to find the gradient of the line, right? That is the use of that tan alpha, clear? Then we found the gradient as 1. Then we know the coordinate of this point, right? Because this point, right? I will mark it like this. Here, this point's coordinate is actually 2, 0, right? Because we found that x is 2, gradient is 1. I'll take a point x, y, right? Then you can see that actually y minus 0 over x minus 2 equals 1. Therefore, y equals x minus 2. Can you remember the general form of the equation? You can write in that way also if you want, right? It is not a must. Either this way or this way correct. Okay? Then this is the equation of the line. Okay? Equation of the line. Right. Okay, now, yeah, I'll discuss another one example, then we can understand what are the steps should be followed to find out the equation of line of action, right? Now, please take new x, earlier y is the new y also, then mark the new triangle, find the magnitude of the resultant, direction, so we found the resultant, then put the general principle of moments. Right, okay. Now take the third part and write down the third part. If the magnitude of the force, if the magnitude of the force along OB, if the magnitude of the force along OB is increased by, if the magnitude of the force along OB if the magnitude of the force along one by one diagram use different colors, that will be easy, right? Along OB is increased by 20 Newton, is increased by 20 Newton to the original system, to the original system. The original system means without this 12 Newton, okay, right? To the original system. If you want, you can mark within bracket without 12 Newton along OA, right? Original system, right? Without 12 Newtons along OA, right? To the original system. Then find the resultant and equation of line of action of the resultant. Then find the resultant and the equation of line of action of the resultant. Then find the resultant and the equation of line of action of the resultant, right? Okay, now, actually this is a very simple thing, right? If the force magnitude, right, along OB is increased by 20 means, right? Can you tell me what is the new force along OB? Rahul, what is the new force along OB?
40 newtons.
40 Newton, right? Now I mentioned increased additional, right? Increased by 20 means then new force is 40 Newton, right? Then actually you can find very easily, right? Capital X equals, earlier all the values, right? Algebraic summation of horizontal components was 0. Then you will be having addition actually 20 cos theta. Okay? 20 cos theta means actually 20 into, right? Then 4 over 5, right? Then here 4, then you get 16. Okay, 16, right? And then, right? Actually, because of this is an inclined force, right? Its effect to the vertical force also will happen, right? That means how can you take that new y, right? New y means the earlier y is what? 12, right? Then 12 plus actually 20 sine theta, right? That means you will be having, right? Here 3, here 5 means actually 4. 4 into 3, then 12, 12, 24. Clear? Right? The new algebraic sum of the vertical components is 24 newtons. Okay? Right? 24 newtons. Okay? Now, if you mark them on a triangle, right? So you can understand, right? Here capital X, capital Y, right? I'll take it as beta, then resultant, okay? Our magnitude comes as, now If this part is not clear, please raise your hand before we move to the other part. Please, right? Honestly, you can raise your hand, right? If this part is not clear. Right, good, okay. Then, okay, right, I will explain, right? Now, Rahul, can you hear me?
Yes, sir.
Okay, now come to the discussion because now this should be again through a discussion, right? You know that actually the earlier system, right, without that additional 20, this was 20, right?
Yes, sir.
All right. Okay, now the ones who didn't understand, listen carefully, okay? All right, now this is 20 Newton earlier. So when you take the algebraic sum of the horizontal components of the original system, what is the answer?
0.
0, right? Then you know that you gave an additional force of magnitude 20 Newton, clear? Then if you want to take the algebraic sum of the horizontal components, what do you have to write? You have to write this 10 cos 30 negative, 8 negative, and 40 cos 30, cos theta actually, right? 40 cos theta. If you simplify it, you get 16 Newton. Why is that? Because now you know that earlier this was here 20, no? Right? If the earlier force were 20, 20 cos theta minus 10 cos theta minus 8. What is the answer, Rahul? 0, right?
0. Yeah.
But if we have 20 Newton here, that means 20 cos theta, right? Should be what? Actually 16 Newton, right? Because of the earlier summation is 0 on 0, right? The new x was is what? 16, right? Got it, Rahul?
Yes, sir.
Yeah. Then anyway, now you can see that, right? The earlier algebraic summation, right? If 40 were not there, right? If 40 were not there, the earlier algebraic summation of the vertical component was 12, right? Now it's something like you have another additional force, 20 Newton. 20 vertical component, what? 12, right? 12 plus 12, 24. Clear? That's how we get it, right? So then, right, you can mark our magnitude actually what? 16 square plus 24 square root, right? Anyway, you know that the highest common factor 8, right? 8 into 2, 8 into 3. 8 comes out, you will be root 30. See how, right? If hard, check it later, right? Tan beta equals actually 24 divided by 16. 8 into 2, 8 into 3. Tan beta only needed, but we have to find the resultant. The beta tan is 3 over 2. Now, anyway, understand the slope, magnitude of the slope of this line is 3 over 2. So that means the gradient of this line of action, right? Gradient is actually 3 over 2, right? So we want to find out this distance nu x, right? How can you find out that nu x? By general principle of moments, right? Can someone tell me the answer quickly? Raise your hand, those who found that the distance to the line of action quickly. 30 seconds, right? Within 30 seconds, I won't. Go on, right? Okay. 5 students raised their hand, right? Kavish, can you tell me what is the new length?
1
Sorry?
1 meter.
I'm asking new x.
1,
One, right?
1, sir.
Why is that?
So the moments aren't changed, but the resultant moment by each force is not changed.
because it's a force along OB. Therefore,
Okay. Therefore,
so therefore the y component is 24 of the resultant. 24 into x is equal to 24. F(x) is equal to 1.
earlier the algebraic sum of the moment by each force was 24. Yeah, no? Did you understand? Okay. Melanie, can you explain me?
Sir,
Yeah, can you explain? What is your answer first? Tell me.
sir, 1 minute.
1 minute. How did you get 1?
Sir, same way, Kavish.
Right. Okay. I will explain. Right. Actually, you know that again, if you apply the general principle of moments, right? Moment by resultant. Moment by resultant means the vertical component, no, right? Moment by see here 24, okay? Right? And this is 16, no, right? Then you know that by general principle of moments, right? Right? Moment by resultant means actually 24 into that x equals moment by each force. You know that moment by each force means we are having a moment by this 10 Newton, by this 6 Newton, by this 8 Newton, right? Actually, whatever amount increased by this force, right? It doesn't involve to the algebraic sum of the moment by each force, no? Right? So no moment by this 4 Newton about O, right? So therefore, right, you can see that the earlier 24 again, right, still come in there, right? But if it is hard, you can try. If you write, you can understand. See, right, here 6, right? Then here 10 cos 10 sin theta, 10 sin theta, right? But we have moment only by 8 into 3, clear, right? 24 into x equals actually, right, directly 24, right? How? Right, you can mark it, right? And give an explanation here. The thing what I said, right? If you couldn't get that quickly, watch the recording, right? And put an explanation there, right? Then you will be able to understand, right? Therefore, x equals 1, okay? X equals 1, right? Now, again, we know that the gradient of the line is 3 over 2, here 1 comma 0, right? Therefore, equation of the right line of action, right? Right, so you can see that y minus 0 divided by x minus 1 equals 3 over 2, right? So 2y equals 3x minus 3. Otherwise, 3x minus 2y minus 3 equals 0, right? Either this way or y equals 3 over 2x minus 3 over 2. That also accepted. Okay? But in the exam, you have write only one of these forms. Okay? Right? That's the way. Right? Okay. Please take.